Everyone. So I'm back. As promised, we are going to discover all the chapters of my book, Ultimate Genetic Algorithm with Python. With my co author, Zonun Feliralte, we have written this book exclusively for you. And if you have not purchased it, go ahead and purchase it because it's worth investing. Lot of things you will learn because this space is going to evolve a lot. Okay, and now, having said that, many people asked me why genetic algorithm now. Okay, why you want to write something when everything is large language model, everything is generative AI. So my answer to them was that this space, as I said, is going to evolve a lot, and genetic algorithm is going to play a crucial role in LLMs, in generative AI, in optimization. Uh, there are companies who have already started working on or working with um, evolutionary algorithms, and they have done a couple of work. They publicly announced it. So here is it's a fantastic time, and I'm going to explain you what we have done. Before that, let me quickly check who are on live. Just give me a minute. This is going to be live on YouTube. So let me see who are live again. Mm, 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 mm. So what I'm gonna do is I'm gonna go to my YouTube page and try to log in there. Okay, and let's see how many people have come live. Okay, I'm not seeing many, but that's okay. We'll get started. So again, the name of the book, Ultimate Genetic Algorithm with Python, and what we have promised, we are going to build intelligent and adaptive AI systems with GAs using Python, and you can see a lot of things in terms of machine learning application of GA, deep learning application of GA, multi-agent application, reinforcement learning application of GA. So a lot of things are there, and feel free to go ahead and buy this book. Definitely, you will get a discount. Okay. Remember that I'm going to show you the book again. That this book is the ultimate guide. Okay. Never written, or rather, nobody has written anything like this before. At least I have not read. Okay. So let's get started. What is chapter one all about? Okay. Chapter one builds the foundation of GAs, where we speak about the principles, okay, inspired by natural selection, Darwinian evolution, um, biologically inspired pathways to actually solve the most complex and high dimensional optimization problem across a lot of industries, because we have used a lot of examples, real world examples with near real world data, and we lay the foundation for GAs, where we speak about selection, crossover, mutation. So let's go a little deeper, shall we? In terms of what the chapter one, which is Introduction to Genetic Algorithm, consists of. It talks about a little history, early pioneers of genetic algorithm. Then we directly jump into components of GAs. Now I'll be using the word GA and genetic algorithm alternatively. Uh, we speak about the core components of genetic algorithm: selection, crossover, mutation, and definitely with examples of chromosome representation. How do you represent chromosomes? Because that you really need to understand. Then we speak about Darwinian evolution versus genetic algorithms, the principles, what are the similarities. Uh, then we take a shift towards genetic algorithm versus deep learning. There, where we speak about extremas, minimums, and we all knows that we have learned it from gradient descent, isn't it? We wrote about deep learning approaches using PyTorch, and we wrote about GA approaches using PyGAD because we have used PyTorch and PyGAD a lot. Then we spoke about execution process of genetic algorithm, where we start with initialization, fitness and evolution, selection, crossover, mutation, how to create new population, or in short, generation, then adaptation, and finally termination. So these are the things that we spoke about. Now, people who are just coming into, or just they don't know much about genetic algorithm, I recommend you to read, because this chapter 1 is going to set your founding stone. If you understand chapter 1 properly, nothing like that. How uh, genes are being represented, what are parents, what are chromosomes, what are populations, how what is a crossover point, what is uh, replacing genes and removing genes, how they look like, what are offsprings, a lot of biological terms, what are genotypes, what are phenotypes. But don't worry, we have explained it pretty well in this book. Ranking, we have also spoken about elitism, how what are the crossover methods that we can use, couple of them like single point crossover, 2 point crossover, uniform crossovers, mutation methods, Gaussian mutation, bit flip mutation, swap mutation, scramble mutation, a lot of other mutation. You really need to go through it with examples and purpose of it. So we have ensured that you understand it pretty much, so that the next chapters becomes easy for you. As I spoke, difference between Darwinian evolution and genetic algorithm, we have given at least a table from where you can read and understand, very intuitive. Then we even we have listed the components, GAs and deep learning, how they look like in another table. So it's like genetic algorithm versus DA again, table wise, so the easy for you. And definitely the codes are also there. There are a lot of charts, and so that you can go through. We've spoken about minimas, maximas in deep learning. Again, a lot of charts, a lot of codes. Execution process is listed there. Then we take you through the execution process with the mathematical equations, so that it's easier for you to understand. That sets the ground for the next chapter, and I'll meet you in the next chapter. I'm going to take you through the next chapter, and I'll highlight what they are. So if you have not purchased this book, go ahead and purchase it. This is the book that you should read for all data scientists, Gen AI experts, researchers. Go ahead and buy this book from Amazon. The link will be shared. It is there. I've been posting it on LinkedIn as well. I'm making YouTube videos as well. So let's let's uh, let's go ahead and invest in it. Thank you.